Hello, we're back. A much more earlier in the evening version, which we're hoping to do more of. So, we've seen our Unilunar lander, Unilu, as it were, Lunar Exploration Unit, we called it. And so far, what we've been doing is doing our big retrograde burn to slow ourselves down as if we were coming out of orbit, and then landing on our four little spindly legs here. And actually, early on in my time here in California, back in 2001, I worked a little bit on a project people might have heard of, the Mars Exploration Rovers. Now, mind you, I came in really late to this project, so I didn't do a whole lot with
You
it
got the
before they
shirt.
launched. But I did get the T-shirt,
It's a nice shirt. It's a
and I think
polo.
maybe the coffee mug. Looks like I glitched there for a second. Looks like I'm glitching a lot of times. I don't know what's going on.
Yeah, I saw that too.
I don't know. Anyway, so early on, I didn't have much to do with it because I came in pretty late into it. It was about 2001-ish. They were pretty much got their code going, and I was brought in to help instruct them on a new set of compiler and debugger and the like. It was also my first days at the company, so I had to make it up as I went along, get one chapter ahead, and then you look like an expert. Um, so in any case, during this project, were part of this viewing or rather, we got these videos early on about the whole entry, descent, and landing for MERS, or MER, MERS, which was the 6 minutes of terror and the big retro burn and the parachute that slows you down, and then you drop the package out from the bottom of that. Then, at that point, you see radar ground acquisition begins at 8,000 feet above the surface. Oh, 8,000 feet. 8,000 feet in meters is not
Feet, no
terribly
meters.
high. 8,000 feet in meters is not much. Ours was 15 kilometers that we have in our system where we acquire ground telemetry. So they were going off of sheer uh, uh, what do you call it, dead reckoning, if you will. They knew how fast they were going in orbit. They got a radar target. They said, "Let's go uh, uh, do the descent." It started the descent, so they kind of had a knowledge of where they were, how high up they were, and so forth to do these early stages. But then eventually you get radar ground acquisition. You start getting some descent pictures to figure out where you want to land. Got some extra satellites high up, and then they inflate these airbags. And so you had asked, my wife
Yeah.
had asked, why don't we use these airbags for landing on Luna? Maybe. It could be possible. I don't think we can't, there's no atmosphere, so parachutes aren't going to work. So I don't think that we would have enough airbag to cover getting out of orbit and getting close to the surface. But once we get down, once we've vertically landed, can we airbag and fall over? Maybe put out little landing legs? So that's what we're doing today. We're experimenting with some other ways of landing and then being horizontal. In the case, in numerous cases, there might be a reason why your lander would rather be horizontal rather than vertically stacked. Um, and there's a couple of different advantages and disadvantages that I wanted to talk about just in general. It's somewhat theoretical, of course.
Right.
Um,
We've been talking about this for days,
yeah.
theoretically.
Because one of the thoughts was if you're going to the moon and on the pole there is water ice that is frozen because it's in the complete shadow all the time, and we retrofire over that water ice for a while as we slow down. Maybe not as such a great idea because no doubt we're going to melt some portion of the top surface of that ice with our retrofire. I don't know how much. We don't know how thick the ice is. Maybe we do. We'll see. But if you might have a little problem of liquefying your landing surface, is my point. And having only 3 little legs or 4 little legs, you might tilt over and things like this. If you're expected to land vertically and stay vertically, an unexpected lost landing leg means your craft is lost. So it might be better in an airbag style to kind of spread out the weight, if you will.
I see. Yes.
So here we are on the main one. And
I sound like I'm echoey. Do you have another mic on?
no, should be the usual mix. unless you're being picked up on my mic.
Maybe.
Move it down a little. So let's get the game sound back on. All right, so
game sound.
this is our Una Lunar Explorer, and we've taken most of the code out of this and brought it into a new craft. Cancel. That we showed you a bit of earlier where we landed, and we didn't have any landing legs at all, so we just rolled down the hill. But that would be the Luna module. So this Luna module has all its legs on one side instead of downward. And it has a nice little cargo bay here that might have some instruments. It's got a gyroscope / reaction wheels that allow it to maintain position and direction. Fuel tank, and then I took forever for me to find the batteries. Turns out a battery is just a fuel tank with electricity in it instead of fuel. It took me a second. Actually, it took me a Google.
Longer than a second.
It took me a Google second, meaning I Googled it. However long that actually takes. So since that takes all sorts of electrical power, we have some solar panels on here, and so our mission is to land vertically and then fall over gently. Gently enough to not break a leg.
Will it fall over gently?
Well, it will fall over.
I understand it will fall over.
It all depends on how fast we're going. Let's get this over here and get that over there. Dang it.
I do see it.
So it all depends on how much we can skillfully null out our lateral speeds, as well as be pointing in the right direction when we fall over.
All right.
So there's still going to be a bit of hand flying here. All of the initial flight to the point of hovering is automated. The navigation's a little iffy because I don't have a GPS navigation that I know of. Maybe it's in here. I haven't gotten to it yet. Just like, I want to go to these coordinates on Luna, like you would in a GPS would. I don't know. I don't know if that's in there or not. I haven't tried it. So we're still doing a little hand flying from where we do our initial descent. So let's head on out to Luna. And what we're doing is we're going out to Luna, and we're hanging out near the source of supply of fuel or other things. Did I actually click the button? There we go. And we're hanging out near the source of supply. We're going to fill up this lander, and then we're going to ship it off over to our little moon base area. So it's great having liquid water on the moon. It's great if we can land something that can automatically convert that liquid water into hydrogen, and liquid hydrogen, liquid oxygen.
It looks like it's going to fall down right now.
I know. I had to put that little stabilizing base because, for whatever reason, it's a hillside that they decided is the default launching pad on Luna. But I put that little Soyuz interstage there just to keep it stable for now. So let's pretend for a second that we've loaded this up with fuel or whatever else from this site, and we're getting ready to ship it off to our friends over at the base. So the base is located at a heading of 123 degrees. 123. And I know you don't see what I'm doing in a lot of cases. I have, in the script, we have all sorts of functionality tied to the action groups. So action group 6 modifies our target pitch. Different from our actual pitch because we don't want to change it right now. We only want to change it after we launch. So 5 and 6 change our pitch up and down by 5 degrees. 7 resets it to 90 degrees. Action group 8 and 9 change our target altitude. So action group 4 changes the mode from AGL to ASL. And the purpose of this is it's much more efficient to hover right at an exact altitude than it is to follow the terrain. So once we get where we're going to want to travel at a fixed altitude, sea level based. And then, of course, once we come down towards the surface, that's going to be above ground base to be that 15 meters, which previously was our pad printing height, where we were printing a pad to land on. But in this case is just a way to get down to the point where we could safely tip over without using any retrofire or additional rockets to slow ourselves down, and just take advantage of the springiness of our legs. So we got our course set in at 123. Yes, and we messed it up.
Yes, I saw 123.
123. Okay.
I saw it.
And we've got our heading at 135. This is actually
Let's
a
see,
little
heading
backwards.
at
I'm going to go
135.
that
Your
way.
heading was 123. There it is.
Yeah.
Target pitch.
Target pitch of 135. And then now we have to set a target altitude. And we're going to have a target altitude above ground level for this guy is going to be 10,000. These also change by 1,000 if we're on the ground and by 100 once we're flying. So we can actually change our target altitude hover.
It only shows it to 9,000.4.
9,000?
9,004.0.
10,004. There we go. One more. So 10,004. That's what we wanted to get to. Thank you. Because otherwise we'd land short of our target.
Alright.
So we're ready to take off. 3, 2, 1. And we're over. So I did find out why I wasn't able to control the roll. If you remember from way back, we tried to fly the space shuttle, and we couldn't control the roll. And it's a conflict between the controller, which is now no longer plugged in, and the keyboard. So we've changed our program. We tell it to go to a particular altitude, wait until you get to there and you start going negative speed, but actually wait until you're going beyond a particular negative speed. I think it's negative 12 or 15 meters per second. And if you're going faster than that on this stage, we'll actually switch into retrograde. So right now we take off, we're gliding across the surface, just kind of taking a look. In fact, if we had any cameras or equipment that had to look out over the terrain, you could look around, that kind of thing.
Ooh.
And of course we're not getting too much sunlight at the moment.
Those could be solar panels if you...
If they were in the sun, let's roll around until we get into the sun. There we go. Now we got a little sun on our panels. In fact, let's bring up some stats here. 99% battery, that's good.
Yeah, that's great.
Our velocities. So one of the main concerns we're going to have is if we flop over, which is essentially what we're going to do, what's those final G-forces? Now, if you have scientific instruments in your cargo bay,
that you don't want to shatter,
maybe you have much lower tolerances for your G-forces. But if you've got liquid fuels, they can put up with a whole lot of vibration. Or should be able to put up with a whole lot of vibration. Now, let's see, where are you? 123. Oh, here we are. So, here's our target crater, the one I use for identification. Here's our landing crater. So, we're going to be going fairly quickly as we start coming down towards the surface here. And we're going to try and null out most of the lateral speed. Now that I think about it. Oh, there we go. Okay. I thought I was going to have to do that manually, but no, it took care of it. So now we're targeting 600 feet above ground level, right above the center, or roughly the center, of this crater. And actually, this crater looks like things have hit it at an angle.
Yeah.
And so it's actually got this sort of steeper sidewall. It's not a smooth, even bowl. It's kind of sideways like this.
It's a double. It's been hit twice.
I guess. Or multiple times, at that matter.
Or multiple times.
Especially this, it looks like a smaller version of this big guy here. Right. Once we get closer, you'll see the details. Actually, it doesn't look like... Are we targeting it? Yeah, we should be targeting it well. That's hence all the exact degrees. So the idea is that while we're putting out this big plume to slow ourselves down, we want to have a large area underneath us that can capture that plume, give it space for that plume to dissipate. And if it's blowing away a bunch of regolith at the bottom of this crater, in theory, it's a bowl. You blow it away, the gas gets blown upwards, and because it goes up, it comes down. Even if it's much slower and the lower lunar gravity, it still comes down. And actually comes down somewhat quicker because there's no air, even though gravitationally it's weaker. And really the main idea being that we eventually we'll have blown away all the loose material from this landing area, and we won't have to worry about it. But if we do blow away material, we don't want to send it laterally across the surface because it could then get into orbit.
Is that where the crater you were?
Yep, this is the one. It's a little bit small. It's the smaller front crater.
What are all those things blinking in the background?
Well, that's our moon base.
Oh.
We've landed there multiple times, both vertically and horizontally in the testing. So here we go. So there's our little moon base over here. Whatever we've blown up out of this crater, right? It's whatever that is that we've blown up out of the crater is now falling down and getting out of the way. Now we put a little bit extra force. We're going backwards away from where we want to go at the moment. And this is probably the last lander I attempt to do it all with one engine. Because the idea behind this was that you could save some weight and cost and so forth if you had a single engine with a single fuel and a single fuel system.
So you can have a payload worth of stuff.
More payload. And also these smaller retro engines that they use for landing are usually some exotic fuel, some hydrazine, or I know Mazdan has some green version of a that isn't so toxic.
Yeah, I read that.
And let's go that way. We want to go towards the moon base. Alright, we got a little speed up, and we can go back to vertical, and we'll go at least double speed, shall we? So now, we're clearing our landing area. You know, so we've kicked up dust and made a mess over here, so we're going to go on. And we're at 600 feet above ground level, and this is where we go back to that sea level mode. So here's at sea level mode, we're going to do a lot less of the wobbling.
Let's see that.
Or we should do a lot less of the wobbling.
Do you not have a feedback?
A feedback.
The information that shows you what you're doing.
Oh, the charts?
Yeah.
Yeah, this is probably a good time to bring that up. We're not traveling too terribly quickly. Let's go ahead and bring that up.
So you're going to land on that plateau? I thought you were going to
Yeah.
land in the crater.
No, the goal was not to land in the crater. The goal was to use the crater as a place to capture all of our exhaust.
I see.
And then that way we don't
didn't
mess
get
up our
that.
nice area. So
that's where I missed what you were talking about.
right, because we had to go to full throttle to slow down.
Right.
Well, now
That would stir up a big bunch of...
exactly. And same would be if we had 4 rockets on our sides. That would blow up a bunch of extra dirt too.
Exactly.
So the idea is we're using a lot less thrust to stay hovered, like in the 10%-ish range. And so there's going to be less exhaust plume and so forth.
I don't know, that looks pretty...
Yeah, it's kind of wobbly at the moment.
Looks
I'll
pretty
have to double check it.
exaggerated.
Get this in here, reload. Oh. Hate when it does that. Well, the graphing is not working at the moment. But that wasn't my main concern today anyway.
No. Well, I was just interested to see how much chatter there was, because it seems like there's a lot.
It does seem like a bit of chatter. So now that we've gotten to this point, we can reduce our altitude. And from, instead of sea level, we want to go down to our usual 100 or so meters. And at the same time, this landing should help burn off some of our lateral speed. $305 AGL. And that's actually where we're at. So now let's go ahead and get rid of all our lateral so we don't overshoot our destination here.
Right.
Just getting our surface speed down. Most of our surface speed is in the lateral direction at this point. A little bit more. And let's actually put it in the direction that we're flying. That always helps slow you down, is putting the rocket in the right direction. And so I'm having a little trouble getting it to where I can automate this kind of thing, where we slow down and so forth. But really, I think I'm going to end up having a couple of little retro jets. So just like last time, we pop out the legs briefly. Oh, let's take a look down. Are we on the hillside? We're a little bit on the hillside, but we're going to go down to 15. And we want to be away from these guys a little bit because we are going to put out some extra thrust to stop this descent. So again, anytime you have to put out a lot of exhaust, you want to be further away from your friends. This is a good rule for everyone. If you're going to put out a lot of exhaust, move away from your friends. Everyone will love you for it. And then when we're down at 15 meters, we don't need much more or less.
You flap your legs.
How's that?
What are you gonna flap your legs?
I flap when I flap the legs out to trigger this descent to 15 meters, so that we can then decide whether it's flat enough. And look how close we are to the other guy. That might not be completely kosher.
Hello,
Alright.
new person in the room.
So now we get this lined up with our legs. Oh. And before we completely scooch off into oblivion, let's try flopping over, shall we? Oh, we flopped over the wrong way. Oh, that's okay. Dang it.
It's like a cow.
I know, he's a little doggy, or a little cow. Alright, roll over on your legs.
You're the goat, the fainting
Good
goat.
rocket. There you go.
Aww.
Now stand up. That's a good little rocket.
Aww.
Now, ideally, he would have flopped the other way onto his legs. But that's a piloting error,
awesome.
Not a coding error.
That's awesome.
And I never claimed to be a great pilot. So... There, I accidentally put his legs down instead of hitting the mute button. Alright, so there's our friend. He's up here with this other vertical lander guy. And we have some other folks down here. So now we just have to make sure that... part of the problem is I really need to be going 0 in order to prevent myself from falling the wrong direction, as it were, because it's essentially trying to fall in the... It pushes itself over, but it pushes itself over in the direction it's headed. So whatever direction you're kind of drifting at. Now when you hover at 15 meters above ground level, and the ground level is the hill, well then you constantly move down the hill, or move up the hill, depending on which direction you have the majority of force. So you really need to be on perfectly flat terrain in order for this to behave, and I really needed to be out closer in this area. So that's where we're going. That is what we are going to do next. We are going to save that guy this time, and we're going to give it a shot with a different style. The Lunamod with the airbags. So in the game, there's no such thing as soft body physics that allow you to simulate something soft and squishy like an airbag. So these are fuel tanks. But since fuel tanks are also batteries, it's okay that fuel tanks can be airbags too. I just need to put in some... I can lower the strength of the airbags, the airbag tanks, so that if they get too much force when they land, they would actually... Well, they might explode. That wouldn't be too good if your airbags exploded on you.
That would defeat my purpose.
Right. So again, we're going to 1, 2, 3. Oops. 123. 7 was supposed to also put you in the right direction of your current heading. Something doesn't behave right with it, but In any case, 135 for the takeoff angle, 123 for the heading, and in this case, we do want to take it up to only 9,000. That has to do with the difference in the mass of the two craft, in order to target that same landing crater. So you ready? We ready? Let's ready. Let's go. 3, 2, 1, and we're off.
There it goes.
So since I practiced all this without rotating, doing the rotation for the solar panels, we're just going to leave it.
Alright.
Plus, we got lots of battery. We're not really burning a whole lot of battery in these stages, since there's no air resistance or anything. We just kind of coast along. So one thought I had was actually from my Loran days. Loran, for anyone who was born in the last 25 years, is low resolution GPS. Very low resolution and not quite global. In fact, less than global. Really only used by shipping. There was a time in the early 90s when they thought they were going to use it for aircraft, and they tried to use it for aircraft, but at the same time GPS satellites were going up. So GPS eclipsed Loran for aircraft pretty quickly. And plus Loran is plus or minus 100 yards. That's how accurate it is. So for a ship, that's fine, because the ship could be 100 yards long. But not so great for aircraft, and certainly not good enough for any kind of terrain navigation on the street. But what Loran D had, Loran C was the terrestrial-based system. They had big stations in New York. In my case, it was New York and Nantucket, someplace Florida, the Mid-Atlantic chain, which was out in nowhere, Oklahoma. And those stations would send out highly timed signals, and based on the difference of you receiving those signals, you could triangulate your position. It's exactly the way Loran or GPS works. GPS just uses higher frequencies, more satellites, more stations, and a higher accuracy clock. But what Loran D did was they had originally deployed it, I think it was Vietnam, and that allowed local navigation based off of these trucks transmitting a master signal and a slave signal and a repeat signal, and those would be, they were actually called X-Ray Yankee Zulu, and then when they needed a fourth they called it Whiskey, but Whiskey came last. Anyway, so the master signal would go out, and then the other ones would repeat after it, and based off of that time differential you would be able to figure out where you are. But what was key to that was the difference in time between the master and the secondary signal could be adjusted, because these trucks were located in wherever they parked the truck instead of being fixed places on Earth. And then you could confuse the enemy, as it were. Even if they had a Loran receiver, their reception signals would not be timed correctly, and it would tell them they're someplace else in the world. All that being said, we could probably land a series of, let's say, vertical local GPS or local Loran for Luna Loran, I guess. Or Luna GPS, ground-based GPS instead of Luna GPS, the Luna Positioning System. It's an LPS. So we could have a surface-based LPS system with a few towers around the area of that's of interest. You don't necessarily have to have navigation across every part of Luna or the moon. You really only necessarily need navigation, high degree accuracy navigation around the various spots where you have interest, like in this case our little moon base.
So you're going really fast?
Talking very fast?
No. Those rockets!
Oh yeah, he's slowing down. He'd be fine. He's all coated all right. There you go. And then vertical you go. Almost vertical. Let's make sure you're vertical now. Alright, now we want to get over to this plateau, so we really want to go that way. All that being said is that the systems for, I guess it's easier now. I mean, it would be easier, probably easier to put a a Luna navigation system, positioning system in orbit about the moon than it would be to land several different individual transmitter stations, considering how many landers have been lost so far on the moon. It is probably safer to be in orbit, or easier to put things in orbit, I should say. Alright, leaning over to zero out our speed. This time I have to make sure I actually keep ahead. So the little green and the green dot and the green arrow are showing those are our prograde and retrograde markers. So the diamond's showing what direction we're going. So of course if we put thrust slightly off from that direction, then we're going to start moving sideways and this kind of thing. Alright, we're coming down to 3, 2, 1, and go back to vertical. Alright, now that we're not moving very quickly in any direction, we can pick which direction we'd really want to move. Yeah, because doing this will make me look around the spacecraft, right? I'll be able to see the other side. It's not a virtual reality game. It looks like it's about that direction. If we line up the... Oh no, not quite, huh? I suppose I should have written down the coordinates or the angles I needed to go at. Go angles. Ah, that's clear. Alright, now tilt forward slightly. Give ourselves some surface speed. See, we're not actually traveling in the direction of that blue circle yet. We're traveling in the direction of the green arrow. But it is slowly creeping up onto a line up here. Bling, bling. So for anyone just joining us, this is a reasonably accurate, although not exactly accurate, model, with the limitations of the game involved, of the Centaur V upper stage, which is, by all accounts, the favorite platform to try and reuse for various landers. And cargo, transport, and things like this. It's essentially one humongous, well, it's two tanks. You're welcome. It's two tanks. And, there's a lot of empty space once you drain the tank of fuel, correct? And so you could fill it up with other things. And I think it's not even, I want to say it's probably about a 1/4 inch thick steel, if that, and it's pressure stabilized, which is to say it doesn't have enough strength to support something heavy on top of it unless it's already pressurized with fuel. It's the same thing that keeps a soda can from crushing while you standing on it until there's one tiny fracture in the sides and then it all collapses. So they use pressure stabilized fuel tanks a lot, partly because they were going to have pressure in them anyway. Look at that. We end up over the ridge as it is. Let's go that way. So we just have to really accelerate it. And then I could come down off of this high altitude. Come down off your high altitude, I tell you. We can just, well, we got 900 feet above ground level, so let's drop, oof. We want to eventually be 100 feet above ground level, but not over this big old canyon, right? So look, we're now 1,000 feet above ground level. That's just because we're over this canyon. So let's just wait a moment. Well, we can probably drop one. And the reason I do this is because I don't have the retro rockets. The only time I actually fire anything is when I'm trying to stabilize my altitude. So by dropping altitude a little bit, I can get a little bit stronger firing. Here we're coasting down again. Getting down to 56, 74. And those little bursts of stabilization for our altitude are going to allow me to get moving the other direction. I'll start using more fuel that direction. Now you can see the little arrow coming around. But we're also gaining a whole lot of speed. So it turns out I can do the opposite thing. go this direction, and then actually start backing up and slowing down. But by slowing down by pushing this way, I can also get moved over. Because we got a lot of slowdown to do. Alright, we're not slowing down fast enough. We're just going to kill the slowdown directly. By using direct thrust. And by keeping us, again, by keeping ourselves angled back like this, what it means is that we're expending more thrust laterally than we are down. Not literally more, but a little bit more. And by doing a little bit more, we can slow our lateral speed. So the more we angle, the faster our lateral speed drops. But of course, the more fuel we use. We have a fairly large amount of fuel. These missions don't take a lot. I have to keep up with... There we go. I'll let that just coast for a little bit, and we'll start going that way just a touch. So we can take a look down, since we don't have our data, unfortunately. We're going to have to guess about how smooth the ground is. Back to vertical. You know, that was supposed to lock us on our current heading, and it's not at all our current heading. It's weird. I don't know. Again, don't know if it's a bug or I'm just misinterpreting what they mean by it.
Is it the game or the gamer?
The infinite question, huh? So this is a good place to slow down and drop down. In fact, let's drop down.
It looks like a flat place.
Let's change mode. Every time I change mode, I lock my altitude to the current altitude. Let's change mode and get down to 100. Well, 66 then. And then as we're traveling downwards, we can kick ourselves back to get rid of that lateral. Because once we start firing to... There we go. That's not too bad. 5 meters per second surface speed isn't too horrendous. We were a little away from our friends. We spent all of our big fuel or big plumes a nice distance away from our friends, so we didn't make a big mess. And let's see. Get rid of that last bit. It's always easier to just completely come to a stop and then change your direction.
Stop. Drop.
Yeah. Alright, when the dots go away, that's when you know you're pretty much at 0. There we go. I want to go that way. Go back over to our friends.
You're not going to your friends.
We're getting there.
You are not.
4 or 5 meters a second. Let's keep it small so that we don't have to do too much braking. Plus, we're only 66 meters above ground
But in
level.
reality, yeah, are you blowing dust now?
I am blowing some dust. Both game dust and dust out my throat. But we are blowing up some dust here. It's just I'm only using 6, 7, 10% of power. So I'm not using so much extra power like I have to when I directly land. And then, of course, when I get up here, I'm going to slow down by blowing some exhaust their way. But just so that I can get back down to that 15-meter level. Let's see. Let's start slowing down. Slow down early.
Well, I'm surprised at how far you got.
Here we're coming up on our couple of little doggy friends. Our cow friends. Cow robots. Robot cow. 2, 1, 0-ish. There, we get it down to 1 meter a second. That should be a good speed. We'll come into this field. I don't know, where do you want to land? In the shadow of the parachute? The uphill parachutes. There's our other little guy that just landed. Well, that's probably a good altitude for that. Let's see. We'll pop out our... Well, you don't really see the legs pop out because we don't have legs. But we trigger to the descent to 15 meters. And like I said, this would be pad printing height, but it was really just the height at which we do our belly flop. So, out with the airbags.
Oh.
Poof. There's your airbags.
Oh.
And we want to zero out that lateral. It just so happens that it is west. And this looks like a good way to go. You ready for a landing?
I'm ready. Let's see.
Whoa, flop. Bloop. There we go. Soft, squishy landing on moon.
See?
On our
I think
airbags.
it can work.
I think it can too. I think it'll actually save weight. You'll only have one fuel. You won't have the bipropellant. I'm blocking. Got a mental block on the type of fuel that I'm thinking of.
I can't think of it either. I just read about it yesterday
Yeah,
too.
a bipropellant. Dang it, can't think of it. Anyway, that other propellant that just ignites on contact. The ignite on contact propellant. Plus the hydrolocks that's in here that would actually take a fuse. So those were the guys we were aiming to show today.
That's awesome.
We got a couple of more landers over on our moon base. Eventually we'll have a rover that can come around and connect up to the docking ports here.
I think that exactly works like I thought it would.
Well, one of the other thoughts I had of this style... No, don't blow it up. Take control. I'm so used to accidentally blowing them up.
Yes.
So here these guys landed fairly closely together,
right.
much more successfully than this guy. The reason I wanted to land horizontally was because it's so difficult to stay vertical and land vertical. Might as well take advantage of flopping over, right? But one of the things I liked about these is the idea that you could lower, and he actually does a little hop when this happens, because those lower so quickly. Oh, see how strong my reaction wheels are?
Yeah.
This is probably stronger than reality. Because I can actually stand up.
Yeah.
Whee! Alright, let's quit trying to break the poor thing. Put out your legs again. Oh, falling over.
Now it was just a spin.
Ah,
Spin now.
I want to dance!
I was born to dance. You can't stop me.
You can't stop me, Dad! I was born to dance! Just flopping around all over. So I don't think the actual reaction wheels would be quite that powerful.
That's funny.
Let's see if I can get him back on his legs at least. Come on, over on your legs. Over on your legs. And there he goes. Alright, now legs out. Be nice and gentle about it. Nope, legs gotta come out super fast.
Oh.
Stand him up. Ah. Just flopping around. You know what? You're problematic. Bye-bye.
Vanish.
Oh, I blew him in half.
Aw,
That's not fun.
That's not okay.
Alright, well, there he goes. Oh, still got some flying solar panels here and there.
Aye.
This is why I always undo these strips.
Way robust. Way more robust than reality.
You think? Alright, well, that's all we had for you this time. Concepts, maybe, could be doable. A little airbag drop over, especially if all you're doing is carrying fuel. Then there's no reason why you shouldn't be able to just do that kind of airbag drop.
So what's your self-whatever spiel?
My self-promotion spiel?
Yeah, your self-promotional spiel.
Yeah, that was, let's see, be sure to like, subscribe, follow, ring the bell, and all those other beautiful, lovely things that let you know when we're doing new stuff. And we'll get all these up on YouTube. You can always go look back at our old stuff there. Be sure to like us, follow us, all those things. If you really want to help, it would really help nowadays if you could support us on Patreon. We got the $3 level for a quick flyby kind of look, and $10 if you really want to help us out. And if you want to provide us some suggestions at the $10 level, you get to offer suggestions, which I know a lot of you want to do. So, so tell us what you think on there. Let us know in the comments and the like, and we will see you guys next time if I can find the right button.
Thanks. Bye-bye.
Thanks. Bye.